In this video, we will learn how to load a sample and the basic software operation of the TGA Instruments Discovery 5500 thermogravimetric analyzer that is used at Rochester Institute of Technology Materials Research Laboratory. This is the image of what the Discovery TGA actually looks like. You have the turret or automatic stage for sample introduction where you actually place your sample on this turret and it gets automatically loaded into the furnace. And then you have the furnace which actually comes around the sample and heats the sample up to high temperatures up to 1200 degrees. And then the touchscreen for manual operation, you can actually control the instrument manually, but we are going to use the software to control the instrument. In this image, you could see the regulators for gas control. On the left image, you could see the turrets which can control whether you have the gas on or off. To turn the gases on, the nitrogen in the air, you would rotate it outward so it's facing you. On the left-hand side is the gauges. They should be set at 20 psi. If they're not set at 20 psi, you could slightly rotate the little gauge knob indicated to get the 20 psi. It should not be more than 20 psi, otherwise you will have problems with flow. To begin with, we will click on the icon called Trios on the desktop of the PC, which will take us into the operating software. Next, we will click on the 5500-0311 and Manufacturing Test button, and then at the bottom we will click Connect. This will take us into a window where we'll be able to design a run. The first thing we must do is to click on the left where the arrow is that says Create a new run. The first thing you'll do is to put in the pan number. The pan number has to match the pan on the automatic stage. So when you put the pan on the automatic stage, in whatever well you put it in, make sure it matches the pan number in the software. The pan type is the platinum pans. Only use platinum pans in this instrument, although you can select aluminum as well, but do not use aluminum pans in this instrument since aluminum will melt at 600 degrees C. There are two types of pans which are important here, the platinum 100 microliter and the platinum high temperature. I designate the platinum high temperature even though I'll be using regular platinum pans in this instrument. That is because in the software platinum will only be good up to 600 degrees and the software will not allow you to run above 600 degrees with regular platinum pans, whereas platinum is actually good up to 1000 degrees. If you want to go to 1200, make sure that you have high temperature platinum pans. The next, you want to come down to segments where you'll be able to fill in and edit a program. So click on Edit at this point. This will bring down a menu, a drop-down menu called Method Segments, where you can pick and drag into the description area any step you want to perform in the program. In this method segment area, you can actually hold down the left button mouse as you hover over any of the steps and drag them into the description area. Then you can fill in the box on the actual values that you want in the program. Here I've got select gas, which is either gas 1 or gas 2. Gas 1 is nitrogen. Gas 2 is always air. And then you can fill in the mass flow. 40 mils a minute is usually good for a mass flow as the gases flow through the instrument. And then you can do a ramp at 20 degrees a minute to 1000 degrees or whatever temperature you would like. And usually what I do is put at the end of the program isothermal that holds the temperature at 1000 degrees for however long you desire. And then I put in another step that ramps it down to 100 degrees so it cools the furnace before it actually opens up for the next sample. When you are done with writing your program, then make sure you hit apply, otherwise the steps will not be saved. Under file name, you can actually click to the right where the three dots are that says save file, and you'll be able to save your file in whatever directory that you create just under Windows like you usually do. In the template area, you can add your own file name, or you can click on add token, and that way the sample name or run date or whatever thing in the drop-down menu which comes up, you'll be able to click on so you can keep track of your samples. To place the platinum pan on the sample stage, hit the screen on the instrument and then hit front, and it'll move the right turret spot to the front of the instrument so you can place the sample pan on it. To take on or off the platinum pan, make sure you use tweezers and fit the sample pan right onto the grooves in each well of the sample automatic stage. Before you run your sample, you must tare an empty pan. To do this, you click at the top of the screen on Instrument, then on Tare. A window will come up with a picture of your turret. Click on the sample pan number that you want to tare. To place a sample into the sample pan, remove the platinum pan from the sample stage with tweezers. Never place the sample into the sample pan while it's on the sample stage. Always remove it. You will only need between 5 and 20 milligrams of sample into the sample pan. Never put more than 20 milligrams of sample into the pan. Once you put the sample into the platinum pan, place it back on the sample stage as shown. Once you do that, you can hit the start on the software, and the pan will automatically be loaded into the furnace. Once the furnace comes around the sample, it'll automatically weigh the sample and start the run. Once you got the information filled in and the program steps completed, then you can hit start at the top of the screen. It'll initially go through a pre-test which loads the sample pan into the furnace, raises the furnace around the sample, and then stabilizes the weight. Then you will begin your run. Now you notice that at the beginning there's some jiggly lines. This is normal. As the run starts off, it'll smooth out in a few seconds after the run progresses. Notice there are two curves. The green curve is a derivative curve which measures on the right axis, on the right y-axis of derivative percent weight per temperature change. The blue is actually the weight loss of the sample. That's indicated on the y-axis on the left-hand side. To analyze the weight loss, click on the weight loss line and drag the line along the temperature range which to analyze, holding down the left button mouse. Then right-click and click on Analyze, and then click on Step Transition. This will give you the weight loss for that particular temperature range. To analyze the derivative curve, you do it in a similar fashion by drawing across the derivative curve, right-clicking, click on Analyze, then on Peak Height, and then Accept. This will give you the peak height of the curve. You can also change the label by right-clicking on the label, clicking on the label, then right-clicking, and go Edit Analysis. If you go to Labels, you can change how you want the label to appear. In this case, we're going to just do peak at X, and then uncheck all the other labels. That'll give me the temperature at which that peak is at. To remove the derivative curve, right-click on the y-axis to the right, then on Select Variable. Then click on Y4, and then uncheck the derivative weight. Click Apply, and then OK. That'll remove the derivative curve. If you have any questions, contact the RIT School of Chemistry and Material Science Instrumentation Lab Manager.